This is day 2 of factoring. Today's focus will be on factoring when a does not equal 1. Remember, a is the number in front of the x squared term. If you haven't done so already, I'd like you to pause the video and try the warm-up problems. So there's 3 of those. We'll come back together and discuss it. All right, the first one, we have x squared minus 8x plus 12. For this example, a is equal to 1, so we can go ahead and use guess and check. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Because it's positive, I know I have to use the same signs, and I would like to get a negative 8x. That means that I'm going to use the 2 and the 6, and both of them would have to be negative in order for me to get the negative 8. Meaning that your final answer is x minus 2 times x minus 6. Okay. Part 2. We have 2x cubed minus 3x squared. In this case, we have a binomial because there's 2 terms. And looking at them, I can see that there is a greatest common factor. So this was from part 1 and 2 and 3 of your notes from yesterday. We're going to factor by pulling out the GCF, which in this case is an x squared. Remember, when we factor using the GCF, we pull out the GCF, and in parentheses, we write what remains. So 2x cubed divided by x squared would be 2x, minus, because I'm keeping the sign, 3x squared over x squared. Well, the x squares cancel out, leaving me with just 3. Part 3, we have x squared minus 5x minus 6. The factors of 6 are 1 and 6, 2 and 3. Now, both of these, the 1 and 6 and the 2 and the 3, can get me to a 5. But seeing that it should be negative, meaning that I have a difference of signs, one being positive, one negative, that tells me I'm going to use the 1 and the 6. If this were a positive, meaning same signs, I'd use the 2 and the 3. So if I want a negative 5x, I need a negative 6 and a positive 1, making it x minus 6 times x plus 1. Factoring when a is not equal to 1, this is where we're going to be using box method. It's just a good way for us to organize our thinking, and it's been pretty successful in the past. There are other ways you could do it if you want to look up Khan Academy or some videos on YouTube if the box method doesn't help, but this is how I'll be doing notes. For box method, remember I introduced it to you in the other video, we create a box and then split that box into 4 smaller boxes. The first term goes in the first box, so 4r squared. The last term goes in the last box, so 1. We then need to multiply these two things together. 4r squared times 1 is a 4r squared. We're going to write out the factors. That would be 1r, 4r, 2r, 2r. I get the 1, 4, 2, and 2 from the factors of 4, and I attached an r to each of these because r times r is what gives me r squared. Now this is a positive 4r squared, which means I need to use same signs to get the middle term. In this case, that would be a negative 4r. Well, I can do that if I make both of these negative. I'll get the negative 4r. You can plug these new terms into the boxes, so negative 2r, negative 2r. And then we're going to pull out the GCF for both vertical pairs and both horizontal pairs. The GCF between negative 2r and 1 is 1. But because there's a negative on the outermost box, we need to put a negative. The GCF between 4r squared and negative 2r is 2, because both of these are divisible by 2, r. Now this is going to be positive because it's positive on the outermost box. Again, being positive because it's on the outermost box, once again we have a GCF of 2r. The GCF between negative 2r and a positive 1 is a negative 1 because there's a negative on the outermost box. Meaning our answer is 2r minus 1 times 2r minus 1. We get that by looking at the GCFs that we put out to the side and on top. If I have something times itself, we could write our final answer as being squared. And that's what I'd like you to do. Number 2. Now before I set up the box method for this one, I do notice that there is a GCF. So whenever we have a GCF, we want to pull that out first. And number 1, we didn't have a GCF. I forgot to mention that, other than 1. So here the GCF was just 1. But here the GCF, they have a common factor of 1 and 2 as well. But the greatest common factor would be 4. So I'm going to pull out a 4. Remember, when we factor using a GCF, we put the GCF on the outside, and in parentheses we write what remains. And we do that by dividing each term by 4. So 8y squared divided by 4 is 2y squared. And then negative 28y divided by 4 is a negative 7y. Negative 60 divided by 4, that's a negative 15. What's in parentheses is what we want to factor by using the box method. So I'm going to use this information when I draw my box. First term goes in the first box. Last term goes in the last box. We need to multiply these two things together. So I'm going to multiply the numbers together. 2 times negative 15, that's a negative 30. And we had a y squared. Now this is negative, so that means I'm going to be using different signs that'll list out the factors. I have a 1y and 30y, 2y, 15y, 3y, 10y, and also 5y, 6y. Using different signs, I want to get to that middle term. Oops, excuse me, I circled the wrong one. Remember, we need to use what's in the parentheses. So I want to get to that middle term of negative 7y. Taking a look, I see that I can use the 3y and 10y. In order to make it negative 7, the 10y needs to be negative, and the 3y needs to be positive. So that'll give me my negative 7y. It doesn't matter where you put the 3y and where you put the negative 10y. I'm just going to put 3y here, negative 10y here. Now we need to pull out the GCF of each pair. The GCF here would be a positive 3. The GCF here would be a positive 2y. The GCF here would be a positive 1y, or just y. And the GCF here is a negative 5. So when I write my final answer, we cannot forget to include the GCF. It doesn't magically disappear. So we still have that 4 out front. And now, in parentheses, I'm going to have y minus 5 and 2y plus 3, because that's a positive 3. 2y plus 3. And that would be our final answer. Next, number 3, if I take a look at this expression, I do see that there is a GCF. The numbers have a GCF of 1, but they all have the k. So I could pull a k out. When I pull out a GCF of k, I'm left with 7k squared minus 22k plus 3. And this is what I want to use in my box. First term in first box, last term in last box. We got to multiply those together. I get 21k squared, which means I'm going to be using same signs here. If I list out the factors, using same signs, I want to get to a negative 22k. Well, I can do that if I make both of these negative. Doesn't matter where I put the negative k or the negative 21k. I'm going to start pulling out the GCF. Here it'd be -1. Here, both are divisible by 7 and have a k, so I'm going to pull out 7k. Between these two, it would be a positive 1k. And then here, it would be a negative, because there's negative on the outermost box, 3. Remember, writing our final answer, we need the GCF on the outside, and then I'll have k minus 3, 7k minus 1. That's our final answer. Number 4, I don't see any GCF other than 1, so I don't have to rewrite this at all. I can go ahead and begin my box method. Drawing my box. First term goes in the first box, last term goes in the last box. Make sure you're bringing that sign with. Now I need to multiply these together. So 7 times -14, that would be a -98x squared. If I write out the factors, this is what I get. 7x and 14x. Now because it's negative, I want to use different signs, and using different signs, I want to get a positive 2. Well, this won't work. Neither will this, and neither will this. So if it doesn't work, it's not factorable. I put this in here to remind you that not every single trinomial of a quadratic function is factorable. It doesn't always work. Number 5, check for a GCF. Nope, it doesn't have one other than 1, so I don't need to rewrite this at all. I can go ahead and start my box. We have my first term in my first box, my last term in my last box. Remember to bring that sign. Multiply these two together. I get a -18a squared. List out the factors. So 1a, 18a, 2a, 9a, 3a, 6a. I need to use different signs to get the middle term of -3a. That is possible if I make this a negative and this a positive. So that gives me a -3a. Doesn't matter where we put the 3a or the -6a, we'll get the same answer. Pull out the GCF. The GCF here would be a +1. The GCF here would be a 3a, because both were divisible by 3 and both had an a. GCF here would be a 3a as well. And then GCF here would be a -2, because there's a negative on the outermost box. Meaning that the final answer will be 3a minus 2 and 3a plus 1.